welcome to this chemistry tutorials. I am Benjamin. In this video we will learn how to use valency to write formula of compounds from their constituent elements. There is using valency to write formula of compounds from their constituent elements. Before we go on to showing these examples, we have to define what a compound is. A compound is a substance which contains two or more elements chemically combined together. Now, it is very difficult to use the name of an element to form a compound, but it's very easy to use the symbols of an element, which we've already learned in the other tutorials, to form the formula of a compound. In so doing, we have to consider the valency. This valency is the combining power of each element, especially as measured by the number of hydrogen atoms it can displace or combine with. You cannot combine two or more elements to form a compound without understanding their valency, because during combination to form compounds, elements exchange their valencies. To study about chemical combination, you can check our tutorials, our videos on chemical combination. That will help you to understand the chemical combination. But let me throw a little light on what happens during chemical combination. Each element exchange their valencies during combination, and this exchange leads to the formation of compounds. To understand the concept of valency, remember the electronic configuration of elements. However, using this table will help us to be able to combine the elements, each of these elements, to form compounds. Let us look at the videos. Now in the table, we look at hydrogen. Hydrogen have an atomic number 1, and the electronic configuration is just 1, and the valency is 1. Helium have atomic number 2, the electronic configuration is 2, and the valency is 0. I will explain why it is 0. Lithium have atomic number 3, and the valency is 2, 1, 2, 1, and the valency is 1. Beryllium have atomic number 4, the electronic configuration is 2, 2, and the valency is 2. As you can see, right up to the 20th element, the electronic configurations are given in the table, and from the electronic configuration you can actually derive the valency for each element. From the table here, you can see that the outermost shell of each electronic configuration of elements represents the valency of the elements. In lithium, the electronic configuration is 2, 1, as you can see here. Now, the valency is 1 because we consider the outermost shell, the shell that is the last shell from the inner side of the configuration. So this represents the valency of the elements. Now we go to beryllium that have 2 at the outermost shell. The valency is 2. Boron 3. The valency is 3. Now we go down to where we have sodium, which the outermost 2, 8, and 1. The outermost is 1. So we have the valency to be 1. Magnesium is 2, 8, and 2. The valency is 2. Aluminium, the same thing, 2, 8, and 3. And so we have the valency is 3. But you will discover that elements like nitrogen, oxygen, and fluorine do not have their valency according to the outermost numbers. Their valencies differ according to the outermost number. In this case, we take our mind back to stability of element during chemical combination. There we observe that element in group 8, or you call it group 0, do not react in whatsoever, and because their outermost shell are completely filled. Let us take something like neon, atomic number 10. There you see that this is the K shell with 2 electrons, and the outermost shell, which is the L shell, with 8 electrons. So this denotes stability, which we call the octet configuration. This octet configuration denotes stability. So such elements with this stable nature do not combine and do not transfer their electrons whatsoever. That is why they have their valency to be 0. You can see this in helium, see it in neon, and see it in argon, which the outermost shell is completely filled. And so there is no way for additional electrons, and there is no way for an electron to be given out. However, other elements in the periodic table tend to attain this stability by either accepting or gaining electrons, or by donating or giving out their electrons. So in this case, I want to use like 3 elements to explain. Let's look at sodium with atomic number 11, and the configuration is 2, 8, and 1. We look at something like magnesium with atomic number 12, configuration of 2, 8, and 2. And let's look at something like chlorine. Chlorine with atomic number 17, configuration of 2, 8, and 7. Now, each of these elements tends to attain stability. By stability, the element will fall back to its the element before it, or will climb up to the element before after it. Elements that have their outermost shell ending at 1, 2, or 3 tends to give out the number of electrons in their outermost shell, and the number of electrons they give out denote their valency. For example, sodium outermost shell is having only 1, which is this is K, L, and M. On the M shell, sodium give out 1 electron in order to attain the stable configuration of neon, which is an element before it. And this electron that is given out is the valency of sodium. The same thing with magnesium. It gives out 2 electrons here to attain stability, and that stability leads to the configuration of neon, and this 2 is the valency of magnesium. But coming to chlorine, the number of electrons in the outermost shell is 7, which is very big. Scientists have it, chemists have it that the number of electrons in the outermost shell here is big, and so to transfer it, the energy that will be required will be high, and so this element cannot transfer, rather it will accept. Now this number must rise to 8, which is the configuration of argon for stability. 2, 8, and 8. Now to attain this configuration of argon, this element needs to add 1 electron to it, and this electron that is needed to add to it is 1. So that is why chlorine on this table is 1. So for writing a chemical formula of any kind to form a compound, you use the valency of each element to write such formula, as we're going to see here. In this example, you are asked to write the formula of calcium chloride. And in doing so, 2 things must come to your mind: the symbol of the element calcium and the symbol of the element chlorine. The second thing that will come to your mind is the valency, which you go back to the table I gave to you and look at it, that the valency of calcium is 2 on that table, and the valency of chlorine is 1. Now, after exchanging their valencies, put them in a bracket. When you put them in a bracket, whatsoever is in the bracket with the element symbol goes with it. So calcium is 1 and chlorine is 2. This is the formula for calcium chloride. It's very simple to write, isn't it? Now, please, if you have not subscribed, subscribe and click on the subscription button for more videos. So more examples will be given in the part 2 of valency of compounds. Thank you.